Hey, welcome, and thank you for your time. This is GitCat Adventure, curious tales for frontend rebases and monorepo. My name is Pillippa, and today I am software engineer focused on frontend. Also, I am community builder in Community US, that is a nonprofit in Chile, and also a director in a nonprofit called Niñas Pro, that's also in Chile, that helps girls between 14 to 20 how to code in C++ free. So, as a cat person, I like TD runs, and also I like TD stories. And also, one of the things that I feel that is interesting Git is because you can do a lot of things that it can be really messy stories and has these stories and also decrease the time when you know some commands that are really important in Git. And you can slow us down with the time. So first, sometimes Git feel like a herding cat. Is something that we daily struggle with iterated rebases, lost commits, incomplete and merge, and also sometimes the time in the clone is very huge. It's like you are waiting and spending your time seeing how the console try to download all the repository. And also sometimes the git log can take a lot of time. So this is the main issue sometimes when you have a huge monorepo. One of the things that is similar to the cats when they jump, they can land on their feet. So Git can too also do that. For that, there are 4 techniques in the large that Git has. That one is rebase and conflict management, that also Reflog based on recovery, and also smart cloning strategies and performance optimizations. So we will start with the story that this is panic. We were in a call. We have so many things to see. And one of these is see the repo and see where is the error. And it's like, oh my God, the error is there, but I don't see it because sometimes we have something like this. Fits, final fit, final, actually final, merge conflict resolution, and fit merge conflict resolution. So the story, it can be something that it can be 200 commits. It can be increased to 2,000 commits. So it can be a namer if you are in call or something trying to find the error. So for that, I see something that is the solution to use. That is Git rebase, and you can create atomic commits. And you can use the squash and reward and drop that was mentioned in the last talk. You can start to create from several commits that you have and do one only commit. That is a very atomic commit. So with that, you can solve the issue that you have a lot of commits that doesn't have the story, the real story. So instead to have linear commits, because when we have several commits that has no meaningful story, it can be that Git needs to save that information, and it's saved in the Git folder. And when we are doing all this, the rebase, and we are pack this commit, we have something that is creating a tree. So we will have a order log n. So we will do clean stories, fast operation. For example, we have other thing that is very important when we are doing something. And when we are doing merge or rebases, we have the rerere. And what do the rerere? When we activate rerere, this remember what was the merge and what you did for solve that. So it's very good when we have, for example, SCCF files or some files in your preferred language, and you are thinking that, oh, I solved this conflict before. Why I am solving this conflict again and again in every time and in the rebase? So if you activate rerere, this will help you because it will maintain all the information in the file. So this is a number that is following some reference that I will put in the final of the slides. It's also following that the repository that is the kernel, that is like a huge repository, Linux kernel. So it's like you can have 90% of time saving if you're using rerere. Other the things that is happening is when we do something bad. For example, we are solving an error in the desperation, we do something like the cat jump, and the jump doesn't work. So we use git reset hard head one, and we spend 3 hours of work, and it's gone because you delete the last commit. Do you delete the last part that you have? So for that, it's Reflog. With Reflog is the way that Git know every step that you are doing. If you are doing, for example, a reset, a commit, a rebase, or other commit, Git has this information. So with Reflog, you can pick the head that you want, and after that is something that it will be bring back in a way that you will choose what is the context that you want to come to life again. So in that case, the lost commit, it was the one and was restored, and all changes and staging and all the context was restored too. So from panic to relief in one command. It's like when we lost some information, it's very tough, and it's like, why I did that? And after that, oh, Git has the solution, Git has the context, Git has all the information that I did. So this is the part that when we have some error. But what is happening when we are in onboarding? We are download, clone a repository, and the repository is giant, is a huge monorepo. And sometimes you don't want all the information, so you will use a Sparse checkout. With a Sparse checkout and also the count, you can specify what folder that you want to download. Because as a front-end engineer, sometimes we don't need the backend size, we don't know all the other folders. We need some specific folder. With that, you can reduce the time, and also it can be that repository for 50 gigabytes to 2 gigabytes. That is the working directory that you need. And following this idea about a house, and you don't need to carry all the house, because it sits something called git clone filter block node. That is the option that is only a tree. That is how is what has this repository, and in the tree is all the information. So when you need that information, this will fetch, and this is similar to have a sync or lazy loading for Git repositories. So these are the main error, and also download, the clone, the repository that are really good for decrease the time that we spent doing using Git. So it's smarter, it's faster, it's calmer for a cat. So we can spend, for example, an IDE like 10 minutes, because sometimes when we open the IDE, we have 10 minutes, and we can decrease 29 each seconds. And also the clone size will be reduced, and also the onboarding time that we spend is waiting that this will be cloned and download, it will be reduced. So it's less way, and you can feel relaxed and all the things. So the next step is we saw the error, we saw them regarding to the download, but we will see now regarding to the performance. We have commit graph. Commit graph is a graph that has every node in a way that, for example, you do a commit, and you need to know what is the information, what file was modifiers, and all these kind of things. So Git has this information in this file, and the commit graph, and when you activate that command, this will be pre-calculate that information, and pre-calculate that information. That means that you have a cache about your Git, about your all movements, and this achieved some velocity when you open your IDE. And also, one of the things that is very important to know is that this saves all this, that is the parent-child relationship, and also the dates, the metadata that there are, and so it has all the topology and timestamps. So the second one is the bitmap, is the negotiation shortcut. It's when the server and the client speak in a way that the server wants to know what are the changes. So for that, you can use this command, and this will create a bitmap. And the bitmap has the information that it was send it to the server, and also the information that is in the client. It's similar to when we are students, and also we are with the attendance list. And when we don't have to activate this command, we have the attendance list like start to ask for every file and ask if this file has changes in the server. Instead, to use this, when you use this command, that means that you have pre-calculated this attendance list, so you know what file has the changes and what file doesn't have these changes. So it's very good because in that way, the negotiation, it will be more fast. And for that, the push and the pull and the merge will be more faster because you know ahead what is the changes. And the last one is the MIDX. That is one index to rule them all. And this is similar to have a library where you have a catalog and also a lot of books. So we saw that, for example, the comic graph is saved, and also the information from the attendance list, that is the bitmap, is saved in the pack files. In that case, you will have a lot of pack files. And if you not activated IDX, you will have something that is not you don't know what is the file that you need to see. So in that case, you need to activate this command, and with this command, you will have a file where you can see, okay, I want to know this file, this line in the code has these parents and also has these times, and you will see the catalog and you will search for this file in a way that they told you, okay, it's in the child 3, section 2. So you have the reference to see this file instead to see all the files that are in the catalog, in the Git folder. So, like that is like you have the tree, and instead to have an order like a end, log end, we will have log end as activating this command. So one catalog for all. So we have the refactor in performance. We have the comic graph, that is this graph that knows where is the parent, what is the child. We have the bitmap that knows what is in the server and what is the client, and have this attendance list that he knows all the information. And we have the MIDX that has the catalog. So we have these three, and we can be stuck then, and we can have more velocity. So we are cut very fast. So now, finishing the presentation, you have 4 quick wins today. And there are some comments that I encourage you that use and see what is the time. And there is a really good reference where they put the time that it was when they applied the comic graph in the Linux kernel repository and the time, and you can see all this chain. So you have the rebase and rerere, that is good for clean commits and config saving history. You have the reflog and reset for recover your lost information. And you have the sparse and partial clone when you want to have a really small part of your repository and decrease the time that you spend seeing your console when you are doing clone the repository. Faster onboardings. And comic graph, bitmap, and MIDX for velocity in a way that when you do Git status, Git log, or even when you do Git merge, or you want to do Git log graph, you will see in faster way because this is catch all the information that is, who is the parent, who is the children, and this bring all the information that is very fast. And also, if you open your IDE, it will be also, because the indexation, it will be more fast. So some reference, there are a lot. So thanks. My contacts if you have some questions. And thank you for your time. My name is Pillippa, and like a Git can be grateful, like a cat.